So last time when we left off, we were in this laggy place. I need to turn off subtitles. And that should help considerably with lag. So, let me explain this place. Correction, let me exit then enter to get awesome music. This is saying there's a thing there. It's pointing to the observation tower. This is 15, enclosed in symbols. Wrong button. So yeah, that diagram and this, they go together, and they mean something. They meme something. Memes. This is a sign. Are the books still broken? Yep, good. So yeah, basically now we have a shortcut. By shortcut I mean an alternate path. And so now we need to go do something. And by do something I mean... memes. No. And by that I mean literally do everything other than what I'm supposed to be doing. So now that we've opened the other path, we can actually move this. No. We can actually move this around. And yeah. And now we have a path over here. So yeah, but this door is still locked. It will be locked for a while, and there's nothing more to do here. But if you'll notice that there's actually a top path, so that path is now opened up because it's in the same horizontal alignment, on the same angle as this, meaning that now by moving it like this, we can gain access to that. But we also have access to the other part of the town via Farley's communications center. But before we do something along those lines, we're going to do something along those lines. I really changed my mind fast. So yeah, we're going to be going along yonder. And in actuality, we need to go over here. I forgot what I'm supposed to be doing. But I do know that has nothing to do with that right there. Okay, yeah, I know where I'm supposed to be going. I need to go yonder. Also, this door over here never opens. Also, can we get this weird door glitch? It was really weird. Yeah, there we go. See? The handle, it's weird and broken now. Don't ask. I don't know why it happens. But now we can go over here and take a right, because there's nothing to the left. And go through this wall. And now where are we? We're by the waterfall, and the waterfall is very noisy. Let's get away from the waterfall. So we were just over there, up there, and now this path is opened up, because it wasn't before, and now we can do that and lower down here, and this is a shortcut. Just something a bit handy, nice shortcut there. You can actually just use that weird clip thing I mentioned earlier, switching to point and click mode, and just go up here. It's because this game is well programmed. But either way, if we go yonder to here, there's a button that does nothing. Good button, 10 out of 10. But here's the thing, and here's a telephone dial. Oh, that says 2 if you can't read it. That says 7 in case you can't read it. That says... Wait, is that 7 or 5? That's 5. The first one is a 7? I can't tell. Either way, that's a thing. That's a very stupid puzzle that we'll be coming to later. Maybe this video, probably not. Either way, because we can go through here. This takes us to a completely different area. And wow, that volume is loud. You can turn that volume down. So we can go across here. And here's the thing. And here's the secret keypad thing. We need a 3-digit combination, and it's not 333. Because if it was 333, that would be very stupid. Either way, so that's the other side of the tower. We can actually go across here, and this is a weird thing. Whatever could this be? I'm not gonna tell you, because I'm rude. No, I'm not. Instead I'm going to lag everywhere, all over the floor, and go over here. Here's a bridge. Yep, that certainly is a bridge. And you certainly can't do anything else here. Good, remember that bridge is there. It's actually vital. In fact... yeah, just in fact, the bridge. It's vital. Can we not get stuck on rocks? Thank you very much. Let's go through here. And back over here. And we can actually go down here. It took me a while to find this path. And this actually takes us to a different place. That's where we were originally. And over there is the road to Farley's house, but this is a bit higher up. And if we go through here, along this mysterious pathway of many origins. Mysterious pathway of many origins. Good. We come across here. Whatever could this be? I'm not gonna say. Here we have a thing that, for mysterious reasons, doesn't work. Except it's not actually mysterious reasons. It doesn't have electricity, which is good, actually, because if that did open up right now, that would be stupid. Yeah, that's a shortcut for later. And by later, I mean like 10 minutes from now. Because right now we are going to have some fun with minecarts. Insert minecart music theme from some video game here. Probably like Paper Mario. Probably not from Paper Mario. Long story, don't ask. I don't even know myself. But basically what we are doing is we need to go here. So, do you recall these weird glowy rocks? All 2 of them? We're gonna blow them up. Because they're red, and red things go boom, remember? And we've got a portable boomy device. So yeah, we're gonna enter this thing and be off on a minecart ride. We can go to the left, but that is literally useless and has no point anywhere whatsoever in the entire game's plot. We can't change tracks there, but we can, and we will have to. Actually, no, that's for later. Actually, no, that's for never. Yeah, tracks crisscross around a lot in this place. So we can go this way, but you'll quickly find out that we actually can't because of that weird thing in the way. You'll see what that weird thing in the way actually is later. Like in 2 parts, I would imagine. 1 or 2 parts. So yeah, we need to get the laser thing to fire forwards. Now we need to go this way. So yeah, we need to fire these rocks with the laser, which means we have to use the laser from this relative direction. And then boom! Like magic, suddenly the pathway opens up, and you can see a broken imager crystal thing, as there's also one up in that thing that we saw earlier, with all the notes that we couldn't read. The graphics in this thing are actually pretty good. Like, you actually have full forwards and backwards control of this thing. And you can spin 360 degrees. It's actually pretty well designed. I will give them that. This minecart was well done. But anyway, if you'll recall correctly, there was some red glowy rock stuff over here. So with the perfect angle of approximately 104.7 degrees, was it? You probably have no idea what I'm talking about. And I think I missed. I indeed did. Let's get this slightly better angle. There we go. Now you'll notice that my character shadow is back on. I turned you off. There we go. We can go back through here, and here's another portal thing. And welcome to the junkyard. Here's the other edge of that path thing we saw earlier. There's a portal that we never go into. And, there's a beetle thing. That beetle thing is actually one of the, native species of, that I mentioned earlier. The RI or something. We can go up here, and then we can go across here, and then we can read, or pretend to read, this book. It's just a supply list. It's literally useless. It's pointless. I don't even know why it exists. But somewhere around here is a whale. Yeah, that sounded weird. Here's the whale. It's a back reward item. I don't know why it's a whale, but apparently it's a whale. Somebody wanted a whale. And now maybe you'll recognize this. It's that door. So what we can do is open it from this side. And so now suddenly we have access to a roundabout, which we will actually use a bunch of later on, and by bunch I mean one time. But meanwhile, we can take this thing, this forklift thing, down. Don't ask me how that thing has power or whatever. And don't ask me what's actually moving this thing. It kind of just moves up and down on its own, because this thing can go back up too. It kind of just defies physics. Don't question it. So now we're down in the lower junkyard. If I could figure out the way off this platoon. Clearly. Here's just some graphics. And that's the first example of me accidentally hitting the spacebar. Good. Hitting the spacebar gives you a photo. Photos are saved here, and they lag the game. Great, delete it. So yeah. We can explore this place, and quickly you'll see that there's nothing here. And you'll see nothing here. Here's a thing, and on the back side it refers to the manhole or whatever. One of Cyan's first original games. It's just a fun Easter egg. Here is a note that you cannot read at all. That was just pure black smudges. And here's a weird machine thing. It looks like some spider that wants to, like, do something. potentially deadly. So yeah, you'll quickly find out that, yeah, here's the thing. We can't for some reason move this switch, but we can, however, move this one. And that brings power to a bunch of places. Also, here's a note thing some notes that don't really have anything at all. And now you'll notice that this thing comes to life when I go near it. And you'll notice that this thing now works. So now we open to the garage door. Take note of these license plates. They may not look like anything. They may look like some random texture on the wall. They may look like, oh yeah, this is a garage, of course there's going to be license plates and other auto mechanic gear here. That's what I first thought, and I was very wrong. And that has something to do with the stupidest puzzle in the entire game. But we'll get to that later, because right now we've got this thing. It's a weird diagram thing. We can draw stuff on it. Like this. And hit a button. And this happens, and that says 25. Trust me, it says 25. We can input our own numbers. Like, I like how the right hand, like the entire right hand side of that is completely cut off. Like, that says EF, if you ask me. Like, you cannot read this thing at all. Like, the graphics are so bad. But yeah, this is the Vilean counting system. This is how they count numbers, the Vileans. That's particular species. And it's actually kind of complicated. So what are we going to do? We're going to, Shift F? No. Shift F, draw D. I don't know. We're going to be doing some drawing. Now, imagine a grid of 5 dots. That's a grid, trust me. So, the Vilean number system is based on base 4. So normal base 10 has all the digits from 0 to 9. That's 10 digits, because 0 counts. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 digits. That's 9. So base 4 has all the digits from 0 to 3. So it's 0, 1, 2, 3. Now normal counting is basically, you count from 0 to 9 in a single digit being one number. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then after 9, if you add 1 to 9, you get 10. But let's break down what 10 really is. Since 10 is just one, it's just like, we have 0, 9. Since really, 9 is 0, 9. So, when a digit reaches, since basically you can picture like all the digits out on a loop, a reel perhaps, like a wheel, and you just spin the wheel. So 0, spin it to 1, spin it to 2, all the way, and then 9 is right beside 0. And so you get to 9, and then you spin it again, but wait, you're back at 0. The numbers went down, so that's why you spin the next reel up by 1. And that's really what numbers are. It's a placeholder, a value. Basically it's saying that 1 is 1 full completions of this cycle. And so if it was 310, it'd be 3 full completions of this, and 1 full completion of this. It's kind of complicated. Don't question it. But basically that means that the Vilean number system would work as such. It would go 0, 1, 2, 3, 10, 11, 12, 13, 20. Except 20 doesn't mean 2 lots of 10 in base 4. 20 means, it means 9. Actually means 8 technically. So, like the number 10 would mean 4. It doesn't mean 2 lots of 5 or the number of fingers on your hand. It means 4 because 10 really isn't the number 10 as we call it. We just call the number 10 and associate it with the number of fingers on our hands, for instance, because that's where we used to, because we use base 10. But 10 is really, as I mentioned before, it's just a like a placeholder system, a value of symbols, since really all numbers are just symbols which we associate with a value. Like, this might be the symbol for, okay, maybe not that, but like, if we grew up in a different country, like, this might be the symbol for 7, and this might be the symbol for 8. It's just another symbol, but to those people in another culture, they're real numbers. Not to be confused with real numbers, which are completely different. Yeah, but no, those symbols would be real, actual numbers, instead of just squiggles, which we can't understand. So now that we've got that out of the way, let's talk about how they count numbers. So we've got 5 individual dots. That is one single digit. So these 5 dots, and how you draw lines connecting these dots represent digits. So this would be equal to 0 in base 10, our base 10 counting system. So let's just draw a line here. So yeah, no lines is equal to 0. Now it's not just the number of lines. The number of lines equals how much that digit is worth, but also that number of lines indicates like the position of the lines matters. Because you wouldn't draw like a 3 facing upside down. That's an M in the English language. A 3 has to be oriented the correct way. Similarly, these lines have to be in the correct positions. So a line drawn from the top left dot to the middle dot is the number 1. That digit represents 1. And so the digit 2 is represented by 2 lines from the top right to the middle and from the middle to the bottom right, like a sideways V thing, and that equals 2. And then 3, which is the last digit that these digits count up to before looping to the next digit, is the number 3. What just happened? Oh, that was a draw and zoom, I think. Okay, that was strange. Okay, let's try this again. So yeah, 5 dots, and the number 3 is this. It's the number 1, except we've got 2 extra lines. So it's kind of like a rotated T, kind of. It's basically an X, but without a line between the middle and the bottom right. So now that we've got that together, we just have to rearrange the symbols. So, for example, the number, like say we were using base, like ignore the fact that base 10 and base 4 are different values, etc. It's like binary. It's like this is 1, but this is 2. This would be 1, but this is 2. That's not 10, it's just 1 plus 1. There's no other number but 0 and 1, so we set this to 0 and add 1 to this. It's not that complicated. But anyway, so say we had the number 1, 4, 3, 4. So instead of 1, or no, why 4? Let's go 1, 0, 3, 3, 2. So we had that, 1, 0, 3, 3, 2. That's a base 4 number. Only uses the digits from 0 to 3. So we would just replace each number, 1, 0, 3, and 2, with a different symbol. We're just changing what the symbol is. So 1 would be... so it would be this. It would be this. And then it would be... it's kind of hard to draw. And then lastly it would be this. So that would be that digit, that numeral, that integer, that number, whatever you want to call it. Now, what we're going to do is, again, we're going to take those digits, and now we're just rearrange their places. Instead of counting from left to right, where this is equal to 100, etc., this number is greater than this, is greater than that, we're just going to rearrange the places. So we're going to place, we've got 5 digits in like a digit here, a digit here, a digit here, a digit here, and a digit here in a plus shape. And so this is the first digit, this is the second digit, this is the third digit, this is the fourth digit, and this is the 5th digit. We're just going to rearrange where the digits are. And that's basically the Violian counting system in a nutshell, because in case I didn't explain it, this is the Violian counting system we're talking about. The Violians, they're a species in this game. So, for example, the number, let's say, like, if you see these dots, like, it may be hard to tell, but, that is the number 1. That would be 3. So if we that display would read 3, but you can't read the display, so yeah, that's terrible. These displays are hooked up. If you were on a better graphics or resolution, you'd be able to see that you input a number here and it tells you the violin equivalent, or you draw a violin number and it tells you the human equivalent. It just converts the numbers, translates them. But yeah, now what we're going to do is, yeah. So, if you'll remember the thing in Farley's place, no. Apparently it's hard to draw. It said 15. And that gets us 481, I think, or 40. Yeah, it gets us 406. Yeah, 406. Yes. So that's a number. It autocorrects to something else, but it's kind of stupid because it changed. Maybe it means something else. No, you just have to know 48 or 406 or whatever. Anyway, so yeah, back to the violin number system. So these 5 dots here. You know, it'll just be easier if I just draw it again for you. So, the violin number system has dots like this. That may look like a lot of dots, and that may seem intimidating, but really just break it down into groups of 5 dots, like the number 5 on a die. Because really there's only 5 groups of them. There's this group. That's 1. And then there's this group. It uses the same top 2 dots as nodes or starting positions for the lines, etc. But the lines themselves occupy completely different spaces. And so likewise, these dots do the same thing, etc., etc. So we see 5 X's, 5 digits. The center digit is the first digit. The topmost digit is the second one. The rightmost is the third. The bottommost is the fourth. And the leftmost is the 5th. So yeah, now that we've got that out of the way, you can now safely draw numbers pretty effectively. Game, I'm inputting 0. Can you reset? Okay, that was weird. Didn't want to reset. So yeah, say like this is 2. And so now we want to say we go to 3, and now we want to count 1 higher than this. We want to count 4. So we'd set this digit to 0, and this digit to 1, and this digit to 1. This panel is a pain to draw. But yeah, we'd set the topmost digit to 1, and then once that one ran out, we would set this one to 1, then 2, then 3, etc. But I've wasted like 10, 11 minutes of this video talking about the violin counting system. Good! But basically all we needed was 406. That's all we needed of this place. That was a long waste of time. So now that we know 406, let's go back to that 3-digit code that we saw earlier. That was this way. Yeah, I think that puzzle's kind of stupid because most people wouldn't understand the whole violin counting system. That sheet did try and explain it to you, except it was kind of complicated for the layman, the average layman. And, yeah, you couldn't actually read it on these graphic settings anyway. So yeah, so we're just gonna go over here and input the code 406. And it will open this door. And that will actually open a bunch of doors. .406. And boom, this door is open. And there's another keypad here, we can do the same, but it matters not. The door is not going to close again. So now we're in a new place. We can open this door. And it's that door by that tree. By the town. So that's a nice shortcut that we have. A very handy shortcut. And additionally, we can open up another shortcut over here. And so yeah, shortcuts, yay. And I think I'm probably going to cut the video here, and we're going to explore that place next time. Yeah. Just trying to think if there's anything else I didn't mention. Don't think so, so yeah. Oh yeah, I did. Yeah, so now you'll notice that all the lights are on because flipping that switch in there activated a few more lights. These lights represented which places have power or not. Electricity. So now all the places have electrical power. So yeah, we are, yeah, cutting the video.